Hello there, and welcome to the Sleep Well channel. I am so glad you have found your way here. Perhaps you've had a long day, or maybe you are the kind of person who finds comfort not in counting sheep, but in contemplating the vast, quiet mysteries of the cosmos. Either way, this journey is for you. There is nothing you need to do now but rest. Let your body grow heavy and still, your breathing slow and deep, and your mind soften at the edges. Because tonight, we are not looking at beginnings, but at endings. We will drift together through the final chapters of the universe, exploring the many ways that everything we know might one day come to a gentle and final close. But this journey is not meant to be one of fear. These are not stories of sudden catastrophe, but of slow, quiet, and inevitable transformations. Of a cosmos that, after billions of years of light and motion, finally settles into a deep and peaceful rest. In the immense timescales of cosmology, even an ending can be a kind of lullaby. If these calm explorations help you find your own stillness, feel free to like and subscribe. It helps other sleepy souls find their way to this quiet corner of the universe. But for now, let your thoughts drift. Let the world outside fade away. And if you are ready, let us begin. The universe as we know it is expanding. In every direction we look, distant galaxies are moving away from us, carried outward on the slow, steady current of space-time itself. For a long time, we wondered if this expansion would eventually slow, stop, and reverse. But it appears the opposite is happening. An invisible force, something we call dark energy, is gently pushing everything apart, faster and faster with each passing eon. This acceleration points toward the most likely and perhaps the most peaceful of all possible endings. A future known as the heat death or the big freeze. This is not a sudden event, but a slow, gradual fading that will unfold over trillions upon trillions of years, long after our sun has gone dark and the Earth is a distant memory. In this future, the universe continues to expand, and as it does, everything within it grows colder and more distant. The great clusters of galaxies, once bound together by gravity, will slowly drift apart until each galaxy is an isolated island in an endless sea of darkness. From any one of these galaxies, the night sky would eventually appear completely empty, as all other galaxies will have receded beyond the horizon of what can be seen. Their light, stretched and faded by the journey, will no longer be able to reach home. The universe will become a place of profound and silent solitude. Inside these lonely galaxies, the cycle of life and death for stars will also come to an end. Star formation requires vast clouds of cold gas, but as the universe expands and cools, these stellar nurseries will run out of fuel. The gas will become too thin, too spread out, too cold to collapse under its own gravity. The last stars will be born shining their light into an increasingly empty cosmos. And then, one by one, they too will begin to fade. The great, brilliant blue giants will have been gone for ages. The sun-like yellow stars will have long since shed their layers and cooled into embers. Eventually, only the smallest, dimmest, and longest-lived stars will remain. The red dwarfs. These tiny stars sip their fuel so slowly that they can burn for trillions of years, far longer than the current age of the universe. They will be the last campfires in the encroaching dark, casting a faint crimson glow over their frozen, orbiting worlds. But even their time will come. After a lifespan, almost too vast for the human mind to hold, the last red dwarf will exhaust its fuel. Its faint light will flicker, and it will slowly cool, becoming a black dwarf, a cold, dead star, invisible in the eternal night. With the death of the last star, the universe will enter a new era, one of profound stillness. This is the essence of the Big Freeze. It is not an ending in fire, but in silence. The temperature of the cosmos will continue to drop, approaching, but never quite reaching absolute zero. The energy of the universe will have spread so thin that no more work can be done. No new stars can form, no planets can warm, and no life as we know it could possibly stir. What remains will be a scattered collection of remnants, black holes, cold neutron stars, and the frozen husks of planets and black dwarfs, all drifting silently through an ever-expanding darkness. It is an ending that feels less like a death and more like a final, deep sleep. Imagine a vast ocean once filled with waves and light and motion, slowly growing calm until its surface is a perfect, unbroken mirror reflecting nothing. This is the universe in its final state of heat death. All the glorious, chaotic, and beautiful processes that created galaxies, forged stars, and gave rise to consciousness will have run their course. The universe's great story will have been told, its energy spent, its motion stilled. There will be no more sunrises, no more collisions, no more new beginnings. Only a quiet, stable equilibrium stretching into infinity. A peace so complete and so final that it transcends our understanding of time itself. As space continues to grow, even the echo of our beginning will fade. The cosmic microwave background, the faint afterglow of the Big Bang that fills our universe today, will be stretched into wavelengths so long and so faint that they become undetectable. It is the universe's first memory, a whisper from its birth. And one day, that whisper will be stretched into silence. All evidence of the Big Bang, all traces of our shared origin will be lost to the expansion, leaving each corner of the cosmos with no memory of how it all began. The universe will not only be cold and dark, but also timeless, with no great events to mark the passage of eons. This final state is not something to be feared. It is the natural conclusion to a long and brilliant life. It is the universe returning to a state of simplicity after an age of breathtaking complexity. The same laws of thermodynamics that govern a cup of coffee cooling on a table are on the grandest scale, guiding the entire cosmos toward this ultimate rest. The energy is never lost, merely spread so thin that it can no longer gather into light and life. And so, the universe that was born in a flash of unimaginable energy will end not with a bang, but with a slow, gentle, and final exhalation. A sigh that lasts for eternity across a darkness more complete and more peaceful than any night we have ever known. As the last galaxies drift apart into their own lonely pockets of space-time, carried on the silent, ever-quickening current of the expanding universe, the cosmos will settle into a long and deepening twilight. The brilliant, energetic era of star formation. The cosmic springtime we now inhabit will be a distant, forgotten memory, a legend from a time when the universe was young and full of fire. What follows is not a sudden darkness, but a slow, graceful descent into an eternal night, an age defined not by creation, but by the quiet, patient, and inexorable fading of the last remaining lights. This is the degenerate era, a chapter of the universe so far in the future that the entire history of humanity, from the first spark of consciousness to our final achievements, would be but a single fleeting breath within its vast, silent expanse. The sky in this era would be almost entirely black, a perfect and profound emptiness. The ceaseless expansion of space will have carried all other galaxies beyond our view, their light stretched by the journey into wavelengths so long they become undetectable, their presence erased from the visible horizon. The only light remaining will come from the stars within our own faded galaxy, which by then will have merged with Andromeda in a slow cosmic dance to form the great elliptical galaxy some have named Milkomeda. But even this light will be dim, ancient, and tinged with the deep, somber red of extreme age. The once bright spiral arms will be gone. The nebulae will be gone. The vibrant blue of young massive stars will be a forgotten color. The galaxy will be a diffuse ghostly halo of old stars, a city of embers where a brilliant metropolis of fire once stood. The stars that will dominate this long twilight are the red dwarfs, the most common, most patient, and longest-lived stars in the cosmos. Unlike our sun, which burns through its fuel in a brilliant but relatively brief 10 billion years, red dwarfs are paragons of cosmic efficiency. They are small, they are cool, and they are incredibly slow-burning, sipping their hydrogen fuel with a patience that spans not billions but trillions of years. For comparison, the universe is currently less than 14 billion years old. The lifetime of a single red dwarf will be hundreds, even thousands of times longer than the entire history of the cosmos up to this point. They will be the universe's last campfires, the final guardians of light, casting a soft, crimson glow on any frozen, silent worlds that might still be orbiting them in the encroaching dark. Imagine a sky in this far-flung future. There would be no bright constellations to guide a traveler's eye, no shimmering Milky Way arching overhead like a river of diamonds. There would only be the scattered dim points of these ancient red suns, glowing like embers in a vast dark fireplace, their light too faint to cast a shadow. The space between them would be immense, and the silence profound. The great nebulae, those beautiful swirling clouds of gas and dust where new stars were once born, will have long since dissipated their substance, either used up in the final generations of star birth or blown away into the intergalactic void. The galaxy will have become a quiet, settled place, its youthful, chaotic energy finally spent. For trillions upon trillions of years, these red dwarfs will be the only sources of generated light in the universe. Life as we know it, dependent on the bright, warm, and generous energy of a sun like ours, would be an impossibility. But perhaps in this age of perpetual dusk, other forms of existence, strange and slow, could emerge. Any life that might exist would need to adapt to a world of eternal twilight, warmed only by the faint, steady glow of a star that never truly shines, but only smolders with ancient heat. The planets orbiting these stars would be incredibly old, their geology long since gone still, their atmospheres frozen or stripped away. Yet for an almost eternal span of time, these small red suns will hold back the final absolute darkness acting as silent, lonely sentinels in the night. Even the way these stars end is quiet, a whisper rather than a shout. They are not massive enough to collapse under their own weight and explode as supernovae. They will not swell into giant red giants that consume their inner planets. Instead, after trillions of years of steady, patient burning, they will simply and gracefully exhaust their supply of hydrogen fuel. Their internal fusion will cease. With no more energy pushing outward, they will slowly contract and heat up, becoming what is known as a blue dwarf, a brief, hotter, and final phase of their life. But this blue is a fleeting color in the cosmic night. After this phase, they will finally begin to cool, fading into a white dwarf. This entire process will be so gradual, so impossibly slow, that from the perspective of any observer, the star would simply seem to dim over a span of billions of years, its deep red light softening, fading until it is no longer visible to any eye, real or imagined. The end of the last red dwarf will be a momentous though silent occasion in the history of the universe. It will mark the end of the stelliferous era, the great and glorious age of stars. When its last light flickers out and is absorbed by the cold, the cosmos will fall into a darkness more complete and more profound than anything that came before. There will be no more stellar fusion occurring anywhere in the universe, no more light generated from the fiery hearts of stars. The age of starlight, the age that gave birth to us and everything we have ever known, will be over. What follows will be a universe of remnants, a silent, majestic graveyard of what once burned so brightly. But this ending is not one of sorrow. It is one of peace. The universe will have given all the light it had to give. Every star that could have been born has been born. Every cycle of stellar life has run its course and completed its story. The chaos and brilliance of the early cosmos, the violent explosions and beautiful nebulae will have settled into a state of profound and lasting calm. There will be no more supernovae to light up the darkness, no more galactic collisions to reshape the heavens, no more brilliant bursts of creation. There will only be the slow, silent, and graceful motion of dead stars and black holes drifting through an endless, ever-expanding night. In this deep future, time itself will seem to lose its familiar meaning. With no sunrises or sunsets to mark the days, no changing seasons to mark the years, and no great cosmic events to mark the passage of eons, the millennia will blur into one another, indistinguishable. The universe will become a static, unchanging place, governed only by the almost infinitely slow decay of matter and the even slower evaporation of black holes. It is a state of perfect and final equilibrium, a great and lasting stillness. As you lie here now, letting your own mind drift toward that stillness, imagine the last red light of the last star. Do not see it as a symbol of an end, but as a final, gentle ember warming a universe that is ready for a long and peaceful sleep. Let the immense, unimaginable timescales wash over you, a soothing reminder of how fleeting our own worries are in the grand, sweeping story of cosmic history. The universe is in no hurry, and tonight, neither are you. There is only the darkness, the quiet, and the slow, steady, and peaceful rhythm of your own breathing, a gentle echo of the patient tranquil future of the cosmos itself. As the last red dwarfs finally exhaust their fuel and the universe's long twilight deepens into an unbroken starless night, the cosmos will be left with its memories. The brilliant, fiery lives of stars will be over, but their remnants will persist, floating like silent, beautiful embers in the dark. Among these remnants, the most common and perhaps the most elegant are the white dwarfs. They are the quiet ghosts of a luminous past, the cooled and compressed hearts of stars that were once like our own sun. Their story is one of a long, slow, and graceful fade into an eternity of stillness, a final transformation from fire into crystal. When a star, like our sun, reaches the end of its life, it does not explode in a final violent burst. Its ending is far more serene. After burning hydrogen in its core for 10 billion years, it begins to fuse helium, and in this new phase, it swells into a vast and luminous red giant. Its outer atmosphere expands, reaching out to engulf the inner planets. Then, over thousands of years, these outer layers drift away into space, forming a beautiful, intricate, and glowing shell of gas known as a planetary nebula. These are some of the most stunning objects in the cosmos, fleeting ghosts of colored smoke, the final artistic exhalation of a dying star. What is left behind at the center of this expanding cloud is the star's naked core, a dense, intensely hot, and incredibly compact object called a white dwarf. A white dwarf is a star that no longer shines through the fire of nuclear fusion. It is a stellar ember, glowing only with the tremendous leftover heat from its former active life. Imagine a sphere no larger than our own planet Earth, yet containing the mass of an entire sun. The matter inside a white dwarf is so densely packed that a single teaspoon of E, if you could bring it to Earth, would weigh several tons. The immense gravity of the star has crushed the atoms together so tightly that their electrons are stripped away, forming a strange and wonderful state of matter known as electron-degenerate matter. It is gravity that holds this substance together, an almost unimaginable inward pull. But it is the strange laws of quantum mechanics that keep it from collapsing further. The electrons, forced into close proximity, obey a principle that forbids them from occupying the same quantum state. They push back against gravity with a powerful outward pressure, a fundamental quantum law of personal space. And so the white dwarf remains stable, a silent, shimmering jewel held in perfect balance between gravitational collapse and quantum resistance. Our own sun will one day become a white dwarf. In about 5 billion years, it will exhaust its core fuel, expand into a red giant, and then gently shed its outer layers, leaving behind its glowing Earth-sized core. This future sun will be small, intensely hot, at first with a surface temperature of over 100,000 degrees, and it will be surrounded by the faint, beautiful, and expanding remnants of the atmosphere it once held. It will no longer be a source of life-giving warmth for the solar system, but it will continue to shine for an almost unimaginable length of time, a final, solitary lantern where a great and generous star once burned. The universe of the far future, the degenerate era, will be filled with these objects. Trillions upon trillions of white dwarfs will drift through the empty, silent galaxies, the last faint sources of light after even the long-lived red dwarfs have gone dark. But this light is finite, a borrowed glow from a time long past. Unlike an active star, a white dwarf has no internal engine generating new heat. It is simply cooling like a hot iron left in a cold room, radiating its stored thermal energy into the cold, endless vacuum of space. This process is incredibly beautifully slow. A white dwarf will continue to glow for billions, even trillions of years, its color shifting as its temperature slowly drops. It will begin as a brilliant bluish white, then over eons it will slowly fade to a soft yellow, then a warm orange, then a deep red, until its light becomes too faint, too low in energy for any eye real or imagined to ever see again. Its final state is a theoretical object, a cosmic ghost known as a black dwarf. A black dwarf is a white dwarf that is cooled so completely that it no longer emits any significant heat or light. It will be a cold, dark, and utterly invisible sphere of degenerate matter, its temperature having reached near perfect equilibrium with the frozen background temperature of the empty universe itself. It is the true and final form of a sun-like star, a silent frozen crystal of carbon and oxygen, a stellar tombstone drifting forever through the eternal night. However, the universe is not yet old enough, not nearly old enough, for any black dwarfs to exist. The time it takes for a white dwarf to cool to this final, invisible state is thought to be longer, perhaps much longer, than the current 13.8 billion year age of the universe. So, every white dwarf that has ever been created since the beginning of the cosmos is still out there somewhere glowing, faintly continuing its long, slow, and patient journey toward darkness. When we look at these faint ancient stars through our telescopes, we are seeing the future of our own sun and the future of countless other stars. We are looking at a universe of embers quietly and gracefully fading into a serene and final peace. Some of these stellar remnants may be even more extraordinary in their final form. Physicists believe that under the immense and constant pressure inside a cooling white dwarf, the carbon and oxygen atoms that compose it can lock themselves into a crystalline lattice structure. In other words, a white dwarf could in its final state become a giant diamond, a crystal the size of a planet. It would not sparkle like a gemstone in a jeweler's window, as there would be no light left in the universe to catch and reflect. But its internal structure would be one of perfect, ordered crystalline beauty. Our sun and countless stars, like it may one day become a planet-sized diamond, a final, beautiful, and unchanging form of matter, cold and silent in the dark. This future, filled with the quiet, invisible forms of black dwarfs, is not an ending of violence or chaos. It is an ending of stillness and perfect order. The matter that once burned in the turbulent heart of a star will have found its final, most stable state. The atoms will be locked in place, their motion almost completely stilled, their energy entirely spent. It is a state of perfect and final peace, a quiet crystalline monument to the star that once was a memory of light turned into solid eternal form. As you rest here tonight on the edge of your own quiet darkness, imagine that long, slow process, the gentle shedding of a star's outer layers, like a flower letting go of its petals, the emergence of a small glowing core, a final brilliant spark of memory, and then the slow, patient cooling over eons, a journey from white-hot light to a final cold stillness. There is no rush in this story. There is no struggle. There is only the inevitable and peaceful release of energy into the vastness of space. Let the thought of this quiet crystalline transformation soothe your mind. The universe, in its grandest and most beautiful cycles, moves with a deep and abiding calm. And in this calm, there is a profound sense of peace. The same peace that you can feel now as your body grows still, as your thoughts begin to fade like a distant ancient star, slowly and gently into the quiet darkness of your own peaceful sleep. Beyond the gentle and graceful fading of sun-like stars, into the quiet embers of white dwarfs, the universe holds the memory of more dramatic and violent endings. The death of massive stars, those cosmic titans that burn with a brilliant blue-white fire and live their lives in a furious rush, leaves behind remnants of an even more extreme and mysterious nature. These are the neutron stars, objects so dense, so compact, and so strange that they push the very laws of physics to their breaking point. They are the collapsed and hardened hearts of supernovae, and in the far future, their slow and final decline will mark another chapter in the universe's long and patient journey into an all-encompassing silence. When a star, much more massive than our sun, perhaps 10 to 20 times its mass, runs out of nuclear fuel, its core can no longer support the crushing weight of its own outer layers. The core collapses under its own immense gravity in a fraction of a second. This collapse is so rapid and so violent that it triggers a cataclysmic explosion, a supernova, an event so powerful it can briefly outshine its entire home galaxy, releasing more energy in a few moments than our sun will in its entire lifetime. While the star's outer layers are blasted into space as an expanding cloud of superheated gas and newly forged elements, the core continues to collapse inward past the point of a white dwarf. The gravitational pressure becomes so extreme that it crushes the very atoms together, forcing the negatively charged electrons and positively charged protons to merge into uncharged neutrons. What is left is a sphere of almost pure neutron matter, an object no larger than a city, perhaps only 20 kilometers across, yet containing more mass than our entire sun. This is a neutron star. The density of a neutron star is almost beyond our ability to comprehend. A single sugar cube-sized piece of its matter, if you could bring it to Earth, would weigh as much as all of humanity combined. Its gravitational pull is so immense that if you were to drop an object from a meter above its surface, it would impact at a speed of thousands of kilometers per second. These incredible objects are born in the unimaginable heat and violence of a supernova, but they are born spinning incredibly fast, a consequence of the conservation of angular momentum, as the massive, slowly rotating star collapsed into a tiny, compact core. Some neutron stars can rotate hundreds of times per second, their entire city-sized mass spinning faster than the blades of a kitchen blender. As they spin, many of these neutron stars possess immensely powerful magnetic fields, trillions of times stronger than Earth's. These magnetic fields trap and accelerate particles, funneling them into powerful beams of radiation that emanate from the star's magnetic poles. If these beams happen to sweep across the Earth as the star rotates. Our radio telescopes detect them as regular repeating pulses of energy. We call these objects pulsars. They are the universe's cosmic lighthouses. They're beams of light and radio waves cutting through the darkness of space with a precision that can rival our best atomic clocks. For millions of years, they spin silent, rhythmic, and incredibly powerful, broadcasting their existence across the galaxy. But even these mighty cosmic engines are not eternal. Like a spinning top that slowly wobbles and slows from friction, a pulsar gradually loses its rotational energy over time. The powerful beams of radiation it emits carry away a tiny fraction of its momentum with each rotation, causing it to gradually and inexorably slow down. This process is known as spin down. Over millions or even billions of years, its rotation will become slower and weaker. The pulses of light will become fainter, the once perfect rhythm less frequent. The cosmic lighthouse will begin to dim its powerful beam, fading to a whisper, and then eventually to nothing at all. In the far future of the degenerate era, after all the active light-producing stars have burned out, these spinning neutron stars will continue their long and slow decline. The galaxy will be filled with these silent spinning objects, their once powerful beams now faded to a memory. They will no longer be pulsars, but simply old, cold neutron stars, still incredibly dense and massive, but no longer broadcasting their presence to the universe. Like the white dwarfs, they will continue to cool, though their journey to the background temperature of the cosmos will be even longer. They are born in the unimaginable heat of a supernova, but they will spend the rest of eternity radiating that heat away into the cold, empty space around them, a process that takes eons. Their final state will be a sphere of cold, dead neutron matter, an invisible and silent monument to the massive, brilliant star that once lived. They will drift through the dark and empty galaxy alongside the black dwarfs and the frozen, orphaned planets, another part of the silent final collection of cosmic remnants. Some of these neutron stars will have companions born from a binary star system. If two neutron stars are locked in orbit around each other, they will create one of the most elegant and final dances in the cosmos. As they orbit, they radiate gravitational waves, tiny, silent tremors in the fabric of space-time itself. This constant loss of energy causes their orbits to slowly decay, drawing them closer and closer together over billions of years. In the very distant future, after eons of this slow inward spiral, they will finally merge. This collision is one of the most violent and energetic events the universe can produce, creating a massive burst of gravitational waves that ripples across the cosmos and scattering a cloud of newly forged heavy elements like gold and platinum into space. But in the cold, dark, and empty universe of the far future, these events will be incredibly rare and isolated, a final, brief flash of violence in an otherwise silent and peaceful cosmos. For a single fleeting moment, space itself will tremble, and then the silence will return deeper and more profound than before. As you rest here tonight, preparing for your own quiet stillness, picture these incredible city-sized stars. Imagine one spinning with the precision of a perfect clock. Imagine its powerful beam of light, a silent metronome sweeping across the galaxy for millions upon millions of years, a testament to the incredible energy of its birth. And then imagine that light slowly fading, the spin slowing the once perfect rhythm becoming a distant memory. There is no struggle in this process, only the inevitable and peaceful settling of a system that has spent its boundless energy. It is a return to a final quiet stillness, a final gentle spin. Let this thought of immense cosmic calm guide your own mind toward rest. Let the worries and the spinning thoughts of the day begin to slow down, growing quieter and more distant, until they too fade into the peaceful, silent darkness of your deep and restorative sleep. After the last star has flickered out its final faint light, after the white dwarfs have cooled to cold, invisible crystals, and after the last pulsars have spun down into a deep and final silence, the universe will enter its next and perhaps its most profound epoch. This is the black hole era. It is a time so far in the future that it almost defies our ability to imagine a period when the cosmos will be governed not by light and heat and the vibrant chemistry of stars, but by the slow, patient, and inexorable pull of gravity in its most extreme form. The universe will become a realm of pure, unbroken darkness, a vast and silent stage where the only remaining actors are the most mysterious and powerful of all cosmic objects, the black holes. In this distant and lonely age, the galaxies themselves, the great islands of stars that illuminate our current universe, will have begun to dissolve. Over countless eons, the complex gravitational interactions between the trillions of dead stars and stellar remnants will have slowly but surely altered their once stable orbits. This process, called galactic evaporation, will see some objects flung out of the galaxy entirely cast away into the lonely, endless void of intergalactic space. Others will slowly spiral inward, their orbital energy gradually bleeding away, drawn inexorably toward the galactic center, where a supermassive black hole lies in silent wait. The once beautiful spiral arms of our Milky Way and the grand elliptical shape of its merger with Andromeda will be long gone, their structure erased by time and gravity. The galaxy will have become a diffuse, ghostly, and almost invisibly faint halo of cold, dark objects, all slowly and silently orbiting a central, unseen abyss. Black holes will be the last active entities in the cosmos. These are regions of space-time where gravity is so strong, so overwhelmingly powerful, that nothing, not even light itself, can escape once it crosses the invisible boundary of the event horizon. They are formed from the final, complete collapse of the most massive stars, or they are the supermassive giants that lurk at the very centers of galaxies, having grown over billions of years by consuming countless stars, gas clouds, and even other smaller black holes. In the black hole era, these objects will be the gravitational anchors of the universe, the final silent masters of a cold, dark, and empty cosmos. Imagine a universe where the only significant events are the slow, patient, and lonely orbits of dead stars and planets around these invisible centers of immense gravity. Time will pass on a scale that makes the entire age of stars, our current era, seem like a fleeting and insignificant moment. The slow, elegant dance of celestial mechanics will continue, but it will be a slow, cold, and utterly silent ballet choreographed by gravity alone. Every now and then, over a span of millions or even billions of years, a stray black dwarf or a wandering neutron star might drift too close to one of these black holes. Its orbit, will begin to decay, and it will be slowly and relentlessly torn apart by the black hole's immense tidal forces. Before its matter is pulled across the event horizon and vanishes forever from the observable universe, it might for a brief moment be stretched and heated to extreme temperatures. This could produce a faint flare of radiation, a final fleeting whisper of light in the unending absolute darkness. But then the black hole will settle once more, and the profound silence will return as if nothing had ever happened. The supermassive black holes at the centers of the faded galaxies will continue to grow, though ever more slowly, as they sweep up the last remaining stellar debris from their vast, diffuse halos. They will become unimaginably massive, containing the combined mass of billions or even trillions of suns. The universe will become a scattered collection of these colossal gravitational wells, each one surrounded by its own sparse halo of orbiting, long-dead remnants. The distances between these systems will be immense, stretched ever wider by the continued slow expansion of space, making interactions between them almost impossible. The universe will have become an archipelago of darkness. In this era, our very understanding of time is altered in a profound way. Near the event horizon of a black hole, according to Einstein's theory of relativity, time itself slows to a near standstill relative to the distant, empty universe. A single moment for an object as it falls into a black hole could correspond to an eternity for the cosmos it leaves behind. The black hole era will be a time of extreme and bizarre temporal distortion, a universe where the flow of time is stretched, warped, and sculpted by the immense gravity of its last remaining masters. Life as we can possibly conceive of it could not exist in such a universe. There will be no energy sources, no warmth, and no light to sustain it. The universe will have settled into its most stable, lowest possible energy state, a state of maximum entropy. But there is a strange and profound peace to be found in this vision. The universe will be in a state of perfect, unchanging gravitational order. The brilliant chaos and vibrant complexity of its youth will have given way to a quiet, mathematical, and silent elegance. The laws of gravity will reign supreme and unchallenged, orchestrating a final, slow, and graceful dance of dark objects in an endless and eternal night. It is a future of ultimate and profound simplicity. All the complex chemistry that led to planets, all the vibrant biology that led to life, all the light and color and warmth that defines our current universe will have been stripped away, leaving only the fundamental properties of mass, gravity, and the curved silent fabric of space-time. There will be nothing left to see. There will be almost nothing left to happen. It is the universe in a state of deep, final, and unbroken meditation, a mind cleared of all thoughts. So as you lie here on the very edge of sleep, let your own mind drift into that profound and peaceful darkness. Do not see it as an ending to be feared, but as a state of ultimate and final peace. Imagine the silence, the stillness, the perfect and unchanging calm that will one day settle over the entire cosmos. Let the thought of this final quiet reign of gravity be a soothing balm for your mind. Let it be a reminder that all motion, all energy, all complexity eventually, and in its own time, finds its way to a state of perfect rest. Just as your own body right now is finding its way to that same state of rest. Just as your thoughts are slowing, quieting, and preparing to dissolve into the peaceful dark and restorative stillness of your own deep sleep. Even in the profound and seemingly eternal darkness of the black hole era, a time when the universe appears to have reached its final unchanging and silent state, there is a whisper of a deeper, more subtle process at work. It is a discovery that was made not through the lenses of powerful telescopes gazing into the dark, but through the quiet, elegant, and beautiful language of theoretical physics. And it suggests that even black holes, the very symbols of permanence, the ultimate prisons of matter and light, are not truly eternal. They too, over timescales so vast they make our minds ache, will eventually and gently fade away into nothing. This is the story of Hawking radiation, the final, almost silent sigh of a universe letting go of its last secrets. In the 1970s, the brilliant physicist Stephen Hawking embarked on a thought experiment, bringing together the two great pillars of modern physics: Einstein's theory of general relativity, which describes the grand and powerful world of gravity and the large-scale universe, and the strange probabilistic world of quantum mechanics, which governs the fleeting and energetic lives of subatomic particles. He asked a simple but profound question: what happens at the very edge of a black hole, the invisible boundary known as the event horizon, when the strange rules of the quantum world are taken into account? His groundbreaking calculations revealed something extraordinary, something that no one had ever expected. Black holes are not completely black. They should, in fact, emit a faint, steady, and almost imperceptible stream of particles, a thermal glow that we now call Hawking radiation. This ethereal process is born from the strange and counterintuitive nature of the quantum vacuum. Even in what we consider to be perfectly empty space, there is a constant roiling sea of activity. Pairs of virtual particles, a particle and its corresponding antiparticle, are constantly popping into existence from borrowed energy, and then, in a fleeting fraction of a second, they find each other and annihilate, paying back their energy debt. This happens all the time, everywhere, a hidden and silent hum beneath the surface of reality. But at the very edge of a black hole's event horizon, something different can happen. A pair of virtual particles can appear, and before they have a chance to annihilate one of them, can fall across the event horizon into the black hole, while the other escapes into the vastness of space. The particle that fell in has negative energy relative to the outside universe, which decreases the black hole's mass, while the particle that escaped becomes a real particle carrying positive energy away. To a distant observer, it would look as if the black hole itself has just emitted a particle. Because energy and mass are two sides of the same coin, as described by Einstein's famous equation E equals mc2. This slow, steady leakage of particles means that the black hole is slowly, almost imperceptibly losing mass. It is, in essence, evaporating. This process is so incredibly, so unimaginably slow that it has no relevance for black holes in our current universe. For a black hole with the mass of our sun, it would take a time longer than the current age of the universe multiplied by 1 trillion times for it to evaporate completely. The larger the black hole, the colder it is, and the slower the process. The supermassive black holes at the centers of galaxies with the mass of billions of suns would take even longer to disappear. A number so large that it has no name and holds no physical meaning in our everyday world. The black hole era will last for an almost infinite amount of time, with these silent gravitational giants reigning over a dark and empty cosmos. But all the while, this impossibly slow process of evaporation will be underway, a secret process hidden in the quantum foam at the edge of space-time. Each black hole will be shining with a faint cold glow, its temperature just a tiny fraction of a degree above absolute zero. It is a light so faint, so low in energy, that it is a whisper, not a shout, a single photon emitted perhaps once a century or once a millennium. Over these cosmic eons, as they steadily radiate away their mass, they will begin to shrink. And as they get smaller, their temperature will rise and the rate of evaporation will begin to increase. In the final fleeting moments of a black hole's life, after a quiet existence that has lasted for longer than time itself, the process will accelerate dramatically. As its mass dwindles to that of a mountain, then a car, then a single grain of sand, the radiation it emits will become a torrent. In its very last second, with its mass all but gone, the black hole will release a final brilliant flash of high energy gamma rays, a burst of energy equivalent to millions of powerful nuclear bombs. It will be the last light the universe will ever see. After an age of almost complete darkness that has lasted for longer than all the ages that came before, it combined, the end of each and every black hole will be a final fleeting and beautiful firework in the eternal night. Once the last black hole has evaporated in its final silent flash, the universe will enter its true and final state. This is the dark era, or the photon age. There will be no more concentrated matter, no more stars, no more planets, no more black holes. What remains will be a thin, cold, and ever-expanding soup of photons, neutrinos, electrons, and positrons, all drifting aimlessly and eternally through an endless void. All the glorious structure, all the breathtaking complexity, all the rich history of the cosmos will have dissolved into a uniform and featureless sea of fundamental particles. This is the ultimate heat death. It is not just the end of stars, but the end of all organized matter. The universe will be a quiet, empty, and unchanging place with a temperature that continues to drop forever, approaching absolute zero, but never quite reaching it. There will be nothing left to happen. Time itself, as a measure of change, will have lost all meaning. It is the final and most profound state of stillness imaginable. As you lie here resting, preparing for your own peaceful sleep, let the thought of this slow, patient, and gentle evaporation bring you a sense of profound comfort. It is a reminder that nothing, not even a black hole, the very symbol of permanence, is forever. Everything, in its own time, returns its energy to the universe. The process is not one of violence or loss, but of a slow, graceful, and peaceful release. A gradual and final letting go. Imagine the final flash of light from the last black hole not as a terrifying explosion, but as a final, beautiful spark, a quiet and fitting farewell to a universe that was once filled with so much brilliance and life. Let this vision of ultimate and final peace guide you into your own rest, into a place where all of your thoughts and all of your worries can slowly, gently, and peacefully evaporate into the quiet and restorative stillness of the night, while the slow, gentle fade into a cold and dark stillness represents the most likely fate of our universe. There are other more exotic possibilities born from the deepest and most profound mysteries of cosmology. One of these possibilities is tied to the strange and enigmatic nature of dark energy, that invisible ethereal force that is currently pushing the cosmos apart at an accelerating rate. We currently assume that this dark energy is a cosmological constant, a gentle and unchanging pressure woven into the very fabric of space-time. But what if it isn't constant? What if over the vast expanse of cosmic time, dark energy were to grow stronger, its repulsive force becoming more and more dominant? If this were to happen, the universe could face a far more dramatic, though in its own way, strangely elegant end. A final, complete unraveling of reality, known as the Big Rip. This is not an ending of fire or of collapse into a single point. It is an ending of ultimate expansion, of a final and complete release. It is a scenario where the expansion of space itself becomes so overwhelmingly powerful that it overcomes one by one all the fundamental forces that hold the universe together. It would be a process that unfolds in the far, far future. But its progression would be a systematic, relentless, and strangely quiet dissolution of all structure, from the very largest cosmic scales down to the very smallest subatomic threads. In the beginning of this process, many billions of years from now, the change would be subtle, almost imperceptible. The accelerating expansion driven by this strengthening form of dark energy, sometimes called phantom energy, would first begin to isolate the great superclusters of galaxies. These vast collections of thousands of galaxies, once bound together by their immense mutual gravity, would find themselves pulled apart, each one drifting alone into its own expanding pocket of space-time. The cosmic web, that beautiful filamentary structure of dark matter that connects galaxies across the universe, would be the first grand structure to dissolve its threads, snapping under the strain of the ever-increasing expansion. Then, as the eons passed and the repulsive force of dark energy continued to grow, the unraveling would begin to work on smaller and smaller scales. Individual galaxies would be the next to go. The force of dark energy embedded in space would become so strong that it would overwhelm the powerful gravity holding a single galaxy together. Stars would be stripped from their ancient orbits gently at first, and then with increasing speed, flung away from their galactic homes and sent drifting alone into the ever-widening empty void. The beautiful, graceful spiral arms and the glowing dense cores of galaxies like our own Milky Way would be slowly and elegantly pulled apart, their trillions of stars scattered like so many grains of sand on a cosmic wind. The night sky, viewed from any remaining planet, would grow emptier and emptier as even the nearest neighboring stars were pushed away into the darkness. The process would continue its inexorable acceleration in the final dramatic stages of the Big Rip. Perhaps only millions of years before the very end, the expansion would become so powerful that it would overcome the more intimate gravitational forces holding individual star systems together. Planets would be torn from their orbits around their stars, their long and stable dance ended as they were sent spinning off into the cold and the dark. The sun, or what remains of it as a cold white dwarf, would be separated from its family of worlds. The Earth, if it still existed as a frozen barren rock, would become a rogue planet unmoored from the star that once gave it life and warmth, drifting alone in a universe that was rapidly coming undone. And still, the final unraveling would not yet be over. In the last fleeting moments before the end, the fabric of space would be expanding so violently that it would overcome the electromagnetic forces that hold solid objects together. Planets, moons, and even the cold, dense remnants of stars would be pulled apart from the inside out. The very ground beneath your feet, if you could stand on it, would dissolve into a cloud of disconnected molecules. The mountains would crumble, the oceans would dissipate, and the planet itself would be reduced to a diffuse, expanding cloud of atoms, each one moving rapidly away from every other. Finally, in the last infinitesimal fraction of a second, the expansion would become infinitely strong. It would overcome the powerful nuclear forces that bind the very heart of matter. Atoms themselves would be ripped apart into their constituent electrons, protons, and neutrons. And then, in the final instant, even those fundamental particles would be torn asunder into a sea of quarks and leptons. Space-time itself would essentially tear apart, and every point in the universe would become infinitely far from every other point. The universe would dissolve into a state of complete and utter formlessness, with no structure, no particles, and no way to measure time or distance. A true end to everything. It sounds violent, but from a human perspective, if one could witness it, it would unfold with a strange and quiet grace. The process would be so vast, so systematic, and so all-encompassing that it would be more like a slow, inevitable dissolving than a sudden chaotic explosion. It is the ultimate and final victory of expansion over gravity, a final and complete release of every single thing from every single other thing. As you drift toward the peaceful state of sleep, let this idea of a gentle, final unraveling bring your mind a sense of profound calm. It is a cosmic reminder that all structures, no matter how grand or how small, are ultimately temporary. The bonds that hold us together, whether they are gravitational, chemical, or emotional, are all part of a delicate and beautiful balance in the universe. The Big Rip is simply a vision of a future where that balance gently tips in favor of an ultimate and final expansion. Imagine the stars drifting apart, not in chaos, but in a slow, silent, and graceful cosmic ballet. Imagine the final dissolution of all matter, not as a violent destruction, but as a peaceful return to a state of pure, unstructured potential. Let the thought of this ultimate and final release help you to let go of the tensions and the bonds of your day, to feel your own body and your own mind gently unravel into the soft, peaceful, and boundless fabric of sleep. For a long and thoughtful period in the history of science, before we discovered the surprising acceleration of the universe's expansion, there was another equally compelling vision of the end. It was a future that held a different kind of cosmic poetry, a narrative of symmetry and return. It was a future where the great expansion that began with the explosive energy of the Big Bang would not continue forever into a cold and lonely eternity. Instead, it was thought that the collective gravity of all the matter and energy in the universe would eventually act as a powerful cosmic brake, slowing the expansion down, bringing it to a graceful halt, and then slowly, gently, and inexorably pulling everything back together again. This is the story of the Big Crunch, an ending, not of cold and increasing distance, but of a warm, final, and all-encompassing return to the beginning. In this beautiful and symmetric scenario, the far future of the cosmos would begin to look very different from the one we now expect. Billions upon billions of years from now, astronomers on a distant world in a galaxy far from our own would notice something extraordinary through their telescopes. The most distant galaxies, which had been moving away from their own for eons, their light stretched into the red end of the spectrum, would appear to be slowing down. Their redshift, the telltale sign of an expanding universe, would begin to decrease. And then, over countless more years, a new and startling phenomenon would emerge. The light from these distant galaxies would begin to shift not towards the red, but towards the blue. The galaxies would no longer be receding, they would be approaching. The great cosmic tide, which had been flowing outward for so long, would have finally turned. The universe would have begun its long, slow journey of contraction. This would not be a sudden or violent event, but a slow and graceful reversal of the very expansion that has defined our cosmos for its entire life. The fabric of space itself, which had been stretching for so long, would begin to shrink. The distances between galaxies would begin to lessen, and the universe as a whole would start to grow warmer and denser. The night sky, which in the Big Freeze scenario grew ever darker and lonelier, would in this future become ever brighter and more crowded with the light of returning neighbors. As the eons passed, galaxies that had once been separated by millions of light years of cold, dark space would drift closer and closer together. Galactic collisions and mergers, which are already a common and beautiful feature of our current universe, would become more and more frequent. The sky would be filled with the beautiful, swirling, and incandescent patterns of these interacting galaxies, their stars and vast gas clouds blending together in a cosmic dance that grew ever more intimate and brilliant. The universe, which had been growing colder for so long, would begin to warm up, bathed in the collective and ever-increasing light of 1,000 billion approaching stars. In the final dramatic stages of the Big Crunch, the universe would become a very different and alien place. The temperature of the background radiation, the faint echo of the Big Bang, would rise steadily. It would climb from just a few degrees above absolute zero through the temperatures of a summer day to the heat of an oven, and then to a searing heat hotter than the surfaces of the stars themselves. The night sky would no longer be dark, but would glow with an eerie uniform and blindingly bright light, a light coming from every direction at once. In this final, incandescent bath of heat, the stars themselves would begin to dissolve. They would start to absorb this intense energy from the surrounding space, their outer layers heating up until they were completely vaporized. The stars would dissolve not from within as they ran out of fuel, but from the outside, cooked by the increasing and inescapable heat of the contracting cosmos. As the universe continued to shrink at an ever-accelerating rate, it would eventually become a hot, dense, and featureless plasma, a state remarkably similar to the one it was in just moments after the Big Bang. All the beautiful and complex structures that had taken billions of years to form the great galaxies, the shining stars, the stable planets, and even the very atoms themselves would be broken down by the incredible heat and pressure. The matter that had once formed our bodies, our world, our sun, and our galaxy would be merged back into a uniform and undifferentiated sea of pure energy and fundamental particles. The final moment of the Big Crunch would be the universe returning to a singularity, a single point of infinite density and infinite temperature, the perfect and symmetrical mirror image of the Big Bang. All of space and all of time would collapse back into a single infinitesimal point, the grand and epic story of the universe would come to a final, complete, and perfectly symmetrical end. While this scenario is no longer considered the most likely fate for our particular universe, it holds a powerful, almost spiritual appeal. It is an ending of ultimate reunion of a final homecoming. It is a future where everything that was scattered by the explosive energy of the Big Bang is finally, gently, and completely gathered back together. It suggests a cosmos with a finite and well-defined lifespan, a complete and satisfying story with a clear beginning, a long and eventful middle, and a definitive and meaningful end. There is a profound sense of closure in this vision, a feeling that the universe has completed its great journey and has at last returned home to its origin. As you lie here on the very verge of your own peaceful sleep, imagine that slow, gentle, and inevitable return. Picture the distant galaxies in the sky, their faint light slowly shifting from the lonely red of departure to the welcoming blue of approach as they begin their long and patient journey back toward one another. See the night sky growing brighter, warmer, and more filled with the beautiful and radiant light of 1,000 billion approaching stars. Feel the universe not as an expanding and lonely void, but as a great cosmic breath that after a long and slow exhalation is finally peacefully and completely drawing back in. Let this thought of cosmic reunion and final symmetry bring your mind a sense of deep comfort and profound peace. Let it be a gentle reminder that all journeys, no matter how vast or how long, can have a final destination, and that sometimes that destination can be a peaceful and gentle return to the very beginning. In the quiet, invisible, and shimmering world of quantum physics, where particles flicker in and out of existence, and reality is governed by the strange laws of probability, there are possibilities for the universe's end that are so strange, so sudden, and so profound that they challenge our very understanding of what it means to exist. One of these is the idea that the very fabric of the universe, we inhabit the vacuum of space itself, might not be in its most stable state. The comfortable reality we know, with its specific laws of physics, might be like a peaceful valley high in the mountains, seemingly stable and permanent, but with a deeper, more tranquil, and more stable valley lying far, far below. If this is true, our universe could one day face an ending that is not about the slow fading of stars or the graceful contraction of space, but about a sudden, silent, and complete transformation of reality itself. This is the story of vacuum decay. This fascinating and unsettling concept comes from our understanding of the Higgs field, the invisible energy field that pervades all of space and gives fundamental particles like electrons and quarks their mass. The current state of this field, its energy level, is what determines the very laws of physics as we know them. The mass of an electron, the strength of the fundamental forces, the very possibility of complex chemistry, and therefore of life. But some of our most advanced theories of particle physics suggest that our Higgs field might be in what is known as a false vacuum state. It is stable, for now, like a ball resting in a small dip on the side of a large hill, but it is not fundamentally and eternally stable. There may be another more stable state available to it, a true vacuum, with a much lower energy level, like the valley at the bottom of that same hill. If this is the case, then it is possible, according to the laws of quantum mechanics, that somewhere in the vastness of the universe, at some unpredictable point in time, a tiny patch of space could spontaneously and randomly tunnel through the energy barrier and fall into this more stable state. This would be a completely random quantum event, much like a single radioactive atom decaying in a block of uranium. But its consequences would be immediate and cosmic. This tiny newly formed patch of true vacuum would immediately begin to expand outward in all directions at nearly the speed of light, like a perfect and shimmering bubble, forming in a vast and unsuspecting ocean of our current false vacuum. Inside this bubble, reality would be fundamentally different. The laws of physics, as we know them, would cease to apply. The properties of the Higgs field would change, and as a result, the fundamental constants of nature would take on entirely new and unpredictable values. The mass of electrons and quarks could become drastically different. The strengths of the forces that hold atoms together could be altered beyond recognition. The very structure of matter, as we know it, the foundation of our solid and predictable world, would become unstable and would likely collapse into some new, strange form of energy or particles. To an observer inside our universe like us, the arrival of this bubble of new physics would be the most absolute and final end imaginable. It would be a shimmering, silent wall of pure transformation, moving at the very speed of light. Because it moves so fast, there would be absolutely no warning. There would be no way to see it coming, no way to prepare, no signal that could ever outrun it. One moment, the universe would be as it is, with its stars, its planets, its familiar chemistry. The very next, it would be gone, replaced by the new and alien physics inside the bubble. It sounds terrifying, but from a sensory and conscious perspective, it would be the most peaceful and instantaneous end conceivable. There would be no pain, no fear, no dawning realization of the event at all. It would be an instant and complete cessation of existence as we know it. The consciousness that is you, the intricate patterns of neurons and electricity in your brain, the atoms that make up your body, the planet, the sun, the entire galaxy, all would be rewritten into a new and unrecognizable form of reality in less than an instant. It would be an end so swift and so total that it would happen before your nervous system could even register that something had changed. Inside the expanding bubble of true vacuum, the universe might be a very different and perhaps uninhabitable place. Perhaps it would be a universe where atoms cannot form a place of pure chaotic energy and strange new particles. Or perhaps it would be a universe with its own new complex laws, its own potential for structures and even forms of consciousness that we cannot even begin to imagine. We simply cannot know. We can only speculate about what lies in that deeper, more stable valley of existence that the universe could one day fall into. The question of whether our universe is truly in a false vacuum state is one of the most important and deeply unsettling questions in modern particle physics. Current precise measurements of the mass of the Higgs boson and other particles suggest that our universe may indeed be in this precarious, metastable state. However, the calculated lifetime of this state is incredibly reassuringly long, trillions upon trillions of years, a timescale far longer than the universe has existed so far. So, if this is our ultimate fate, it is not an imminent one, but one that lies in the deepest and most distant future. As you lie here tonight, letting your thoughts drift and soften, imagine this bubble of new physics, not as a destructive and terrifying force, but as a silent, shimmering, and pearlescent wave of pure change. Picture it expanding gracefully through the cosmos, not with a roar or a violent crash, but with a quiet, luminous glow, rewriting the very rules of reality as it passes. It is a profound and humbling reminder that the universe we know, with all its familiar laws and beautiful structures, may be just one possible state of being one chapter in a much larger and stranger book. And that change, on the most fundamental level, can be both absolute and utterly silent. Let the thought of this quiet, instantaneous, and complete transformation help you to let go of your own day, to release your thoughts, to release your worries, and to allow your own consciousness to slip silently, instantly, and peacefully into the new and unknown state of deep and restful sleep. From the farthest, most abstract reaches of theoretical physics in the elegant, beautiful, and deeply complex world of string theory comes a vision of the universe that is stranger, more vast, and more magnificent than we could ever have ordinarily imagined. It is a vision where our entire cosmos, with all its countless galaxies, all its trillions of stars, and the entirety of its fabric of space and time, is not the whole of reality, but just one thin, shimmering membrane-like surface floating silently in a higher dimensional space that we cannot see or touch. In this breathtaking picture, our universe is a brain, a shortened term for membrane, and it may not be alone in the vastness of this higher reality. This is the story of brain cosmology, and it offers a vision of an end that is also simultaneously a spectacular new beginning, a gentle and final collision with another universe. String theory, in its attempt to unite all the fundamental forces of nature into a single, elegant framework, proposes that the most fundamental constituents of reality are not point-like particles, but tiny, one-dimensional, vibrating strings of pure energy. For this beautiful and complex theory to work mathematically, it requires the existence of extra dimensions of space, hidden dimensions beyond the familiar three of length, width, and height that we experience in our everyday lives. In some of the most compelling versions of this theory, our entire universe is a vast, three-dimensional brain, a flat and sprawling sheet, existing within a larger, higher dimensional reality that physicists call the bulk. And in this bulk, a space beyond our own, there may be other brains, other universes floating parallel to our own, perhaps separated from us by just a fraction of a millimeter in a dimension that is completely imperceptible to us. Most of the time, these parallel universes would be entirely invisible and inaccessible to us. The forces and particles that make up our reality, like light and matter, would be confined to our own brain, unable to cross the gap into the bulk. However, some physicists have suggested that gravity, the weakest of all the forces, might be an exception. Gravity might be able to leak between these brains, which could offer a beautiful explanation for why gravity seems so much weaker than the other fundamental forces of nature. For the most part, though we would be completely isolated in our own magnificent sheet of space-time, unaware of the other realities that might be floating nearby. But what if these brains, these parallel universes, are not static and fixed in place? What if they are moving, drifting slowly and silently through the higher dimensional bulk, like giant shimmering leaves on a cosmic wind? If so, It is possible that two brains could one day, in the far distant future, drift slowly and inexorably toward each other and eventually collide. This collision would not be like two objects crashing into each other in our familiar three-dimensional space. It would be the collision, the gentle meeting of two entire universes. The consequences of such a monumental event are difficult for our minds to fully fathom, but some of the most elegant models suggest that it could be the very trigger for a new Big Bang. The immense kinetic energy released by the collision of two vast brains could be what ignites a new universe into existence, creating a hot, dense, and uniform state of energy that then expands and cools to form new galaxies, new stars, and new possibilities for life. In this ekpyrotic model of the cosmos, the Big Bang was not the absolute beginning of everything, but simply one moment in an endless, grand, and beautiful cycle of cosmic collisions. Our own universe may have been born from the fiery collision of two previous universes, and it may one day end its own existence in a final collision that gives birth to the next one in the eternal chain. This ending would be profound and all-encompassing. As another brain universe approached ours through the higher dimension, we would not see it coming in our familiar three dimensions. But its presence might begin to be felt perhaps as subtle changes in the distribution of dark energy or gravitational fields. The final collision itself would be an event that happened everywhere in our universe at once. The energy density of our reality would skyrocket in an instant, and all the intricate and beautiful structures that we know, the galaxies, the stars, the planets, and even the very atoms themselves would be broken down, dissolved, and recycled into the raw primordial energy of a new and spectacular creation. It is an ending that is simultaneously and completely a birth. It is a destruction that is also a genesis. It beautifully reframes our entire universe, not as a solitary one-time and perhaps meaningless event, but as one part of a much larger, eternally recurring cosmic drama. It suggests that the cosmos is not just expanding or contracting within its own confines, but is part of a grander, more majestic, and cyclical dance taking place in a higher dimensional space that we can only begin to glimpse through the beautiful language of mathematics. The idea of brain cosmology, of course, is highly speculative and exists at the very frontier of our scientific understanding. We have no direct observable evidence that these extra dimensions or these parallel universes truly exist. It is an idea born from the pursuit of mathematical beauty and consistency, a possible and elegant answer to some of the deepest and most persistent questions in fundamental physics. But as a thought to drift to sleep on it is both deeply calming and profoundly awe-inspiring. Imagine our universe as a vast, shimmering, and impossibly thin sheet floating silently in a space that we cannot see, a space of infinite possibility. Imagine another such sheet, another complete universe with its own stars and its own history, drifting slowly and peacefully toward us over the course of eons. And then imagine the gentle final meeting of these two magnificent realities, a touch that dissolves everything we have ever known, not into a final and empty nothingness, but into the brilliant and hopeful fire of a new and perfect beginning. It is a powerful reminder that in the grandest schemes of the cosmos, endings and beginnings can often be two sides of the same beautiful coin, and that the great story of the cosmos may be a story that is told and retold over and over again in an endless and beautiful cycle of collision creation and quiet cosmic renewal. Let this thought of an eternal and graceful cosmic rhythm soothe your mind and guide you gently and peacefully into the boundless, higher dimensional space of your own deep and restorative dreams. The story of the universe, as we tell it, does not have to be a straight and finite line stretching from a single mysterious beginning to a final permanent and perhaps lonely end. There is another deeply resonant family of ideas as ancient as human philosophy and as modern as the frontiers of theoretical physics that imagines the cosmos in a different and more rhythmic way as an eternal, magnificent cycle of birth, death, and spectacular rebirth. In these theories, the end is never truly the end. It is merely the quiet prelude to a new and brilliant beginning. A moment of transition in an endless cosmic dance. This is the vision of the cyclical universe, a cosmos that does not die but instead breathes in and out over an eternal timescale. We have already touched upon the idea of the Big Crunch, a future where the universe's expansion halts and reverses, pulling all of existence back into a single hot and dense point. In a linear story, this would be the final chapter. But what if that singularity, that point of infinite density, is not a final impassable wall, but a doorway? In cyclical models of the universe, the final collapse does not end in a point of infinite and eternal density. Instead, when the universe becomes incredibly hot and dense, approaching the state of the Big Bang, a new and powerful force, perhaps related to the strange rules of quantum gravity or the properties of extra dimensions in string theory, takes over. This new force would be repulsive, pushing back against the crushing force of gravity and causing the entire universe to bounce. This cosmic bounce would be the beginning of a new Big Bang, the catalyst for a new and explosive cycle of expansion, cooling, and the eventual formation of new galaxies, new stars, and new worlds with the potential for life. In this beautiful and endless picture, our own universe is just one in an infinite and majestic series of universes, each one born from the compressed and purified ashes of the one that came before it. The cosmos would have no true absolute beginning and no true final end. There would only be an endless, soothing rhythm of creation, expansion, collapse, and dissolution, a heartbeat on a scale of trillions upon trillions of years. Each complete cycle, or eon, as it is sometimes called, could last for an almost unimaginable length of time. The universe would expand, grow cold and dark and empty as we have imagined in the Big Freeze, and then slowly, under the influence of some changing cosmic field, it would begin to contract again, gathering everything that was once scattered back together for the next great and glorious bounce. Some of the most elegant versions of this theory suggest that each cycle could be slightly different from the last. The fundamental laws of physics, or the values of the fundamental constants, might be subtly reset or altered with each bounce, leading to a grand and majestic succession of universes, each with its own unique properties, its own unique story. Other models propose that some form of information, some memory of the previous cosmic cycle, might be able to pass through the fiery furnace of the bounce, leaving subtle, almost invisible imprints on the structure of the new universe. If this were true, we might in theory be able to search for these faint imprints in the patterns of the cosmic microwave background, or in the large-scale distribution of galaxies in our own sky, looking for the faintest, most ancient echoes of a universe that existed long before our own. The very idea of a cyclical universe has a deep and ancient philosophical resonance. It speaks to the cycles we see everywhere in our own world and in nature, the constant and reassuring turning of the seasons, the inevitable and beautiful cycle of life and death, the daily and dependable rising and setting of the sun. It suggests that the universe itself, on its grandest and most magnificent scale, follows this same fundamental and deeply comforting pattern of eternal renewal. It replaces the cold and lonely finality of an infinite empty end with the hopeful and beautiful promise of an eternal return. A universe that is always and forever beginning again. There are many different and beautiful versions of this idea, each born from a different branch of theoretical physics. Some, as we have explored, are based on the collision of brane universes in higher dimensions, with each collision sparking a new Big Bang. Others, like the model known as loop quantum cosmology, suggest that quantum gravity effects prevent the formation of a true singularity, instead creating a quantum bridge that connects a collapsing universe to a new expanding one. And still others, like the fascinating conformal cyclic cosmology proposed by the physicist Roger Penrose. Imagine a future where the universe expands until all matter has decayed into light, and then through a strange and beautiful mathematical transformation of scale, this cold, empty, and massless universe becomes mathematically equivalent to the hot, dense, and energetic state of a new Big Bang. In this breathtaking vision, the end of one eon is quite literally the beginning of the next seamlessly and without a violent crunch. As you lie here tonight, feeling your own body and mind letting go, and your thoughts guiding you gently toward sleep, imagine the entire universe as a great cosmic heart, slowly and peacefully beating over trillions upon trillions of years. A long, slow, and graceful expansion, like a deep and cleansing exhalation, as countless galaxies drift apart and their stars slowly fade. And then a long, slow, and gentle contraction, like a deep and restorative inhalation, as everything is gathered back together, renewed and purified, ready for the next beat, the next brilliant and beautiful burst of creation. There is a profound and abiding sense of peace in this rhythmic, eternal, and majestic vision of the cosmos. It removes the stark finality of an ending and replaces it with the gentle, soothing, and predictable rhythm of an endless cycle. It suggests that the universe is not a story that is told only once and then is over, but a beautiful and timeless poem that is recited over and over again, each time with a slightly different cadence, a slightly different meaning, and a slightly different beauty. Let the thought of this endless, peaceful cosmic breath match the gentle and steady rhythm of your own breathing, slow and deep, as you drift peacefully and completely into the timeless, boundless, and restorative space of your own deep sleep. We have journeyed together through cosmic endings, born from the grand and elegant laws of physics, the slow, gentle fading of the universe's last stars, the final, inexorable collapse of gravity, the silent, shimmering arrival of a new and different vacuum. But there is another, more modern possibility for our end one that comes not from the world of cosmology, but from the fascinating intersection of philosophy, information theory, and computer science. It is an idea that challenges not just the future of our universe, but the very nature of reality itself. What if our universe, with all its countless galaxies, all its intricate and beautiful physical laws, and even our own precious and mysterious consciousness, is not the base fundamental reality? What if it is, in fact, an incredibly advanced and complex simulation, a vast and beautiful program running on some unimaginably powerful computer in a reality beyond our own? If so, the end of the universe might be the simplest, quietest, and most peaceful of all, the moment the program is gracefully shut down. This idea, known today as the simulation hypothesis, has been explored in various forms by philosophers for centuries, but it has gained a new and compelling life in the age of advanced computing. The modern argument, often put forward by thinkers like Nick Bostrom, goes something like this: if any civilization, anywhere, ever reaches a stage of technological maturity where it can create simulated realities that are completely indistinguishable from the real thing, it would likely, for purposes of research, art, or entertainment, run many such simulations. If this is even possible, then the number of simulated universes would over time vastly outnumber the one and only original base reality. Statistically, then, based on this logic, it is far more likely that we are currently living in one of the countless simulations than in the one and only original universe. In this strange and mind-bending scenario, the laws of physics that we observe and so carefully measure are not fundamental and immutable truths of existence, but are simply the rules of the program, the underlying code that governs the behavior of our simulated world. The Big Bang might have been the moment the simulation was booted up and the program began to run. The speed of light, that seemingly absolute cosmic speed limit, could simply be the processing speed limit of the computer on which our reality is running. The strange, pixelated nature of space-time that is suggested by some theories of quantum gravity could be the literal resolution of the simulation's underlying grid, the smallest possible unit of simulated space. If we are indeed living in a simulation, then the end of our universe could come in a variety of simple and quiet ways. The simulation could be deliberately shut down because it has served its intended purpose. Perhaps it was a scientific experiment to see how a universe with our particular set of laws would evolve, or to study the emergence of life and consciousness. Perhaps it was a vast and detailed historical reenactment of a long-gone past. Or perhaps, in a more unsettling thought, it is a form of art or entertainment for our unknown creators. In any of these cases, the end could come without any warning, a completely instantaneous and peaceful cessation of everything. One moment, you are here in this quiet room, thinking, feeling, and dreaming. The next, nothing. There would be no transition, no awareness of the end, no final moments. It would be like a character in a complex video game when the power cord is suddenly and silently pulled from the wall. Your existence and the existence of the entire cosmos would simply quietly and completely cease. Alternatively, the end of our simulated universe could be the result of a glitch. A bug in the complex code could cause the laws of physics to break down in unpredictable ways, leading to a catastrophic and irreparable failure of the simulation. Or perhaps the immense computational resources required to run our universe could be depleted or reallocated, causing the simulation to slow down, to freeze, or to become corrupted like a modern computer running out of available memory. This idea is, of course, almost certainly untestable. There is no experiment we can perform from within our perceived reality that could definitively prove that we are in a simulation. Any evidence we might uncover could itself simply be part of the simulation's sophisticated code designed to make us believe we are in a base reality. It is an idea that lives at the very edge of science in the fascinating and boundless realm of pure philosophical speculation. But as a concept to contemplate as you drift gently and peacefully toward sleep, it has a strange and quiet beauty. It reframes our entire existence, not as a random and perhaps meaningless cosmic accident, but as a story, a magnificent and incredibly intricate piece of art, a creation of some unknown and perhaps unknowable intelligence. It suggests that all the struggles, all the joys, all the vastness, and the breathtaking complexity of the cosmos are part of a grand and purposeful narrative. A simulation so perfect that its inhabitants believe it is real. Imagine the end of the universe not as a grand or violent cosmic event, but as the quiet and gentle closing of a book after the final page has been read. Imagine it as the soft and silent fading of a screen after a beautiful film has ended. Imagine it as the final resonant note of a magnificent symphony slowly and peacefully fading into silence. There is no violence in this ending. There is no chaos. There is just a quiet, clean, and complete end to the story. It is a profoundly humbling thought, the idea that our entire reality might be a beautiful and intricate dream in the mind of some other greater being. But it is also a thought that can bring a sense of deep and abiding peace. It means that the universe is not a random, chaotic, and meaningless accident, but a deliberate creation infused with some form of purpose, even if we can never hope to know what that purpose is. Let this thought gently dissolve the apparent solidness of the world around you tonight. Imagine the walls of your room, the bed on which you lie, the very air you breathe as part of a beautiful, complex, and intricate illusion. And then imagine that illusion being gently, silently, and peacefully switched off. It is the ultimate act of letting go, the final and complete release of all form, all thought, all being. Let it be a gentle guide for your own mind as you let go of your day and allow your own consciousness to be gently, silently, and peacefully switched off into the quiet, boundless, and dream-filled simulation of your own deep and restorative sleep. We experience our lives as a constant and unwavering journey through time, a relentless and forward-moving flow from a fixed and unchangeable past through a fleeting and ephemeral present and into an open and unknown future. This powerful and intuitive sense of time's direction, this arrow of time, is one of the most fundamental and defining aspects of our conscious experience. But in the strange, beautiful, and often counterintuitive world of fundamental physics, time is not as simple or as absolute as it seems. And in some of the most profound and elegant visions of the universe's ultimate end, it is not matter or energy that finally disappears, but time itself. This is the story of a far distant future where the very arrow of time dissolves, where the river of time ceases to flow, and the universe settles into a serene, timeless, and static state of eternal existence. The direction of time, the reason we remember the past but not the future, is deeply and inextricably linked to the physical concept of entropy. Entropy is in simple terms a measure of the disorder or randomness in a system. The second law of thermodynamics, one of the most fundamental and well-tested laws in all of science, states that in a closed system like our universe, total entropy can never decrease. It can only increase or stay the same. A broken glass does not spontaneously reassemble itself into a whole one. A cold cup of coffee does not spontaneously grow hot by drawing heat from the surrounding air. The universe, as a whole, seems to follow this inexorable law. It began in a highly ordered, incredibly low entropy state at the moment of the Big Bang, and it has been moving toward a state of ever greater disorder ever since. It is this constant and irreversible increase in entropy that is thought to give time its forward direction, its one-way arrow. But what happens in the far, far distant future when the universe finally reaches its ultimate state of heat, death, the big freeze? In this unimaginably distant era, after all the stars have burned out their last light, after all the black holes have slowly and patiently evaporated, the universe will be nothing more than a thin, cold uniform and ever-expanding soup of fundamental particles like photons and neutrinos. In this state, the universe will have reached a state of maximum entropy. It will be in a state of perfect and complete disorder, with no more structure, no more gradients of temperature or density, and no more potential for change. In such a universe, there would be no more room for entropy to increase because it would already be at its absolute maximum. The system would have reached its final and eternal state of thermal equilibrium. If the very arrow of time, its forward momentum, is inextricably tied to the constant increase of entropy, then in a universe that has reached a state of maximum entropy, the arrow of time would cease to have any meaning. There would be no forward direction, because the state of the universe forward in time would be completely indistinguishable from its state backward in time. The very distinction between past, present, and future would dissolve into meaninglessness. The universe would become a static, timeless, four-dimensional block of space-time with no new events to mark the passage of eons, because nothing new would ever happen again. It is a concept that is almost impossible for our time-bound and forward-looking minds to truly grasp. We are so deeply embedded in the constant and relentless flow of time that we cannot imagine an existence without it. But from the cold and elegant perspective of fundamental physics, it is a logical, even an inevitable conclusion. It is the universe finally reaching its most fundamental and peaceful state of rest, a stillness so profound and so complete that even time itself comes to a final halt. In this timeless and eternal state, nothing would ever truly happen. The few remaining particles would drift aimlessly and eternally through the void, their positions changing, but their overall statistical state remaining exactly the same forever. There would be no memory of the past, because the past would be no different from the future. There would be no anticipation of the future, because the future would hold no surprises and be no different from the present. It would be a universe of pure and eternal is not, was, or will be. This ultimate ending is not a destruction of the universe in any conventional sense. It is a fundamental transformation of its most basic and defining property. It is the universe finally shedding the last vestiges of its dynamic, chaotic, and beautiful past, and settling into an eternal, unchanging, and perfectly serene state. It is a peace so complete and so absolute that it transcends the very concept of duration itself. Some modern physicists, like the influential Julian Barber, have even put forward the radical idea that time is not a fundamental property of the universe at all, but is in fact an emergent property, a kind of powerful and persistent illusion created by the complex interactions of matter and energy within a fundamentally timeless reality. In this view, the universe is always and forever a timeless collection of infinite nows, and our powerful experience of the flow of time is a product of how our conscious memory-forming minds process information and create a narrative of past events. If this is true, then the end of the universe would not be the end of time, but simply the moment when the universe returns to its true, fundamental, and timeless nature, its complex, time-creating structures having finally dissolved away. As you lie here tonight, feeling the gentle, steady, and rhythmic passage of your own quiet breath, let the thought of a vast and timeless universe bring your mind a sense of profound and unshakable calm. Imagine all the urgency of your day, all the striving for the future, all the relentless and demanding ticking of the clock simply and peacefully dissolving into a state of perfect and eternal stillness. Let it be a gentle and soothing reminder that the constant pressure of time that we feel in our daily lives is a feature of our particular complex and beautiful corner of the cosmos, and that beyond it, there is a state of being that is vast, quiet, peaceful, and timeless. Let your own powerful sense of time begin to soften, to blur at the edges as you drift away from the memories of the past, away from the plans for the future, and into the peaceful, boundless, and timeless now of your own deep and restorative sleep. We have journeyed together to the very edge of imagination, to the end of stars, the end of galaxies, the end of black holes, and even to the end of time itself. But there is one final, almost impossibly distant horizon left for us to explore. It is an ending that goes deeper than any other, to the very heart of physical reality, to the fundamental building blocks of everything we know. It is the story of a future where not just the grand structures of the cosmos, but matter itself, the very substance of our world, is not eternal. This is the story of the last quiet and final whisper of the universe, the story of proton decay, the moment when the last solid things in the cosmos dissolve gracefully and completely into pure radiant light. The familiar matter that makes up our world, the atoms in our bodies, the solid rock of our planet, the dense gas in the heart of our stars, is all built upon a foundation of seemingly stable, fundamental particles. At the core of every single atom in the universe are protons and neutrons, which are themselves made of smaller particles called quarks. For as long as we have studied physics, we have assumed that protons, unlike many other more exotic particles, are fundamentally and eternally stable, that they will, if left alone, last forever. But some of the most advanced and elegant theories in modern physics, the so-called grand unified theories that seek to unite the fundamental forces of nature into a single beautiful framework, predict otherwise. They suggest that protons are not truly and absolutely stable, but are only incredibly, unimaginably long-lived, and that over timescales so vast, they make the slow evaporation of a supermassive black hole seem like a fleeting and brief moment. They too will eventually and inevitably decay. The predicted lifetime of a single proton is a number that is almost beyond the ability of human language to describe or the human mind to comprehend. It is a 1 followed by more than 30 zeros, a number of years, so immense that the entire 13.8 billion year age of the universe is an insignificant and fleeting fraction of a single second in comparison. But if this beautiful and compelling theory is correct, then in the far, far, far distant future, in the cold, dark, and almost completely empty universe of the dark era, after all the black holes have gone, the last remaining structures in the cosmos will slowly and gracefully begin to dissolve. Imagine the black dwarfs, those cold, dark, and crystalline, planet-sized remnants of stars, like our sun, floating silently and alone in the eternal darkness. For eons upon eons, they have been the only solid objects left in the entire universe. But now, their final transformation will begin. One by one, their constituent protons will begin to decay. A single proton somewhere deep inside the perfect crystal lattice will spontaneously transform into lighter particles, perhaps a neutral pion and a positron. These particles will then in turn decay into photons and neutrinos, fundamental particles of pure light and ghost-like matter. The very substance of the star will begin to radiate away. This process would be so incredibly and vanishingly rare that in a single object the size of the Earth, you might have to wait for millions or even billions of years to witness a single proton decay. But the universe in this final era has nothing but time. It has an almost infinite amount of time. Over these unimaginable and silent spans, the process will continue, a slow, patient, and inexorable unraveling from within. The magnificent black dwarfs, the planet-sized diamonds, will slowly, imperceptibly lose their mass, radiating it away as a faint, almost non-existent glow of pure energy. They will not melt. They will not explode. They will not shatter. They will simply, proton by proton, molecule by molecule, dissolve into nothingness, their solid form becoming a ghost of light. The same ultimate fate would await the cold, dead neutron stars, those incredibly dense, city-sized remnants of ancient supernovae. Their neutrons, too, which are only stable within the extreme pressure of the star, would eventually decay back into protons and electrons, and those protons would then themselves decay. These massive silent spheres of matter would slowly and gently vanish, their immense mass and powerful gravity converted back into the pure, unstructured energy from which they were once so violently born. After a period of time that is truly beyond any form of counting or human comprehension, the very last piece of solid matter in the entire universe will have finally decayed. The long, brilliant, beautiful, and complex story of matter. The story that began with the formation of the first particles in the fires of the Big Bang will have come to a final quiet and complete end. What then will be left of our once glorious universe? The universe will be a vast, cold, and ever-expanding void containing nothing but a thin, uniform, and featureless sea of photons, neutrinos, and perhaps a few stray electrons and positrons. It will be a universe of pure light, but a light so stretched by cosmic expansion and so low in energy that it is, for all intents and purposes, a form of perfect darkness. There will be no more matter. There will be no more structure. There will be no more complexity. All the information that was once so beautifully and intricately encoded in the structure of the stars, the orbits of the planets, and in the delicate neural patterns of life itself will have been lost forever. The universe will have finally and completely returned to its simplest and most fundamental possible state. This is the ultimate and most profound end. the final and graceful dissolution of everything we think of as real and solid. But like all the other possible endings we have explored together on this quiet journey, it is not an ending of violence or of terror. It is a slow, patient, and utterly peaceful transformation. It is the universe completing its final great cycle, returning the very last of its borrowed mass back to the form of pure, unstructured, and timeless energy. It is the final, softest whisper in a story that began with an unimaginable shout of creation. As you rest here tonight, on the very edge of your own quiet and peaceful sleep, let the thought of this ultimate and final simplicity be a source of profound and deep calm. It is a gentle and soothing reminder that everything we see, everything we touch, everything we are, is ultimately temporary. We are beautiful and complex patterns, but patterns nonetheless formed for a brief and shining moment from a deeper, simpler, and more fundamental reality. And one day, all of the patterns will dissolve. Let this thought help you to release your own patterns, the patterns of your worry, the patterns of your planning, the patterns of your long day. Let them dissolve gently and peacefully into the simple, unstructured, and quiet reality of your own deep and restorative sleep. And so, our long, quiet, and gentle journey through the many possible ends of the universe comes to its own peaceful close. We have drifted together through imagined futures of ice and profound darkness, of all-consuming fire and graceful return, of silent shimmering and instantaneous change, and of the final, complete, and gentle dissolution of everything. We have stood at the cold, lonely edge of the big freeze, watching the last patient stars fade like embers in an infinite night. We have felt the slow, warm, and gravitational pull of the Big Crunch, a great and final cosmic breath, drawing everything back home to its origin. We have imagined the silent pearlescent arrival of a bubble of new physics, and we have witnessed the final lonely and almost infinitely slow evaporation of the last black hole in a final, brilliant spark of light. These are not rigid predictions, but beautiful and profound possibilities. Magnificent stories told by science about the grandest and most unimaginable scales of time and space. Some of these stories are more likely than others based on what we can observe today, but all of them, in their own unique way, share a common and deeply comforting thread, a sense of peace, of natural and graceful inevitability of a universe that, after its long and brilliant life, finally settles into its final, most stable, and most tranquil state. In every one of these endings, there is a serene return to simplicity, a final and complete letting go. Perhaps you found a strange and quiet comfort in the idea of a cyclical universe, an endless and beautiful rhythm of birth, death, and spectacular rebirth, a great cosmic heart that never truly stops beating. Or perhaps you found a deeper and more profound peace in the absolute and final vision of heat death, a great and ultimate stillness where all motion finally ceases and the universe finds a perfect and eternal rest. Or maybe the strange and philosophical idea of our entire reality being a beautiful and intricate dream, a complex simulation that is one day gently and silently switched off brought your mind a sense of wonder and detached calm. Whichever of these stories resonates most deeply with you tonight, let it serve as a gentle and soothing reminder of the immense and breathtaking scale of things. The universe is 13.8 billion years old. Its future, in any of these scenarios, will be measured in trillions upon trillions of years, a timescale so vast it is almost meaningless. The worries and the struggles of a single day, or even of a single lifetime, are but a fleeting shimmering and almost instantaneous flicker in that immense, majestic, and cosmic story. And there is a strange and profound comfort to be found in that perspective. It gives us permission to let go. It allows us to see our own lives not as a heavy and endless burden to be carried, but as a brief, beautiful, and precious moment of awareness in a universe that is overflowing with wonders. For a short and shining time, in this one small and quiet corner of the cosmos, the universe has woken up. In you, in me, in every thinking, feeling, and dreaming being that has ever existed, the ancient stardust has arranged itself into a pattern so complex and so beautiful that it can look back at the very stars from which it came and wonder about their nature. We are, in a very real and beautiful sense, the universe's way of knowing itself. We are its memory. We are its curiosity. We are its capacity for awe. And even if our time in the light is brief, the fact that we were here at all, that we were given the gift of consciousness to contemplate these grand and beautiful mysteries, is perhaps the most astonishing and wonderful fact of all. The end of the universe, in whatever form it ultimately takes, is not our story to witness. It is a story for a time so distant and so remote that our own sun, our Earth, and our entire civilization will be a long and completely forgotten memory. Our story is now. It is here. It is in the quiet and profound beauty of a starry night sky. It is in the comforting warmth of the sun on our skin. It is in the gentle, steady, and peaceful rhythm of our own breathing as we lie here together in this quiet moment on the very edge of sleep. So let these grand thoughts of cosmic endings now gently fade away, like distant ancient galaxies, receding slowly and silently into the night. They have served their purpose for tonight. They have carried you to a place of quiet contemplation, of deep peace, of a broader and calmer perspective. And now, there is nothing left for you to do. There are no more mysteries to solve. There are no more futures to imagine. There is only this one simple and peaceful moment. The quiet stillness of your room, the gentle softness of your bed, the slow, deep, and steady rising and falling of your own calm breath. You are a part of this vast, beautiful, and endlessly mysterious universe. A brief, shining, and precious moment of its consciousness. And now, it is time for that consciousness to rest, to let go, and to find its own peace. If you happen to still be awake, you are welcome to stay in this quiet space, or to let the next video continue your gentle journey. But if sleep is near, let it come. Let it carry you away into that quiet inner universe of your own dreams, a cosmos of your own making filled with its own wonders. Thank you for drifting through the end of everything with me tonight. May your sleep be deep. May your rest be restorative. and may your dreams be peaceful. And so we float here for a moment in the quiet space after the story has been told. The stories we have just shared of cosmic ends and timeless cycles are offered in this quiet space for gentle contemplation and educational reflection, a way to find a different perspective as we prepare for our own nightly rest. We have journeyed through futures so vast and so distant that they feel more like dreams than possibilities. We have watched the last stars fade, felt the universe breathe in and out, and witnessed the final quiet dissolution of matter itself. And now, as the echoes of these immense stories settle in our minds, we might gently ask, what do we carry back with us? What quiet wisdom can be found in contemplating the end of everything? Perhaps the first and most profound lesson is a sense of scale and the beautiful freedom that comes with it. In our daily lives, our worries can feel enormous, like mountains that block the sun. A mistake at work, a difficult conversation, the anxieties of tomorrow, they can feel all-consuming. But as we have just seen, the universe operates on a canvas of time and space so vast that our entire civilization is but a single, fleeting brushstroke. The end of the universe is not a story of days or years, but of trillions upon trillions of eons. In the face of such immensity, the mountains of our own anxieties begin to feel smaller. They do not vanish, but we see them for what they are: small stones in the palm of a hand, held for a moment, that can be gently set down. Contemplating the big freeze or the final evaporation of a black hole is not meant to make our lives feel insignificant. It is meant to make our burdens feel lighter. It is a gentle invitation from the cosmos to release the weight of things that are in the grand scheme so very small. It is the peace of perspective, the freedom that comes from realizing that most of the things we worry about will be forgotten, not in a trillion years, but by next week, or even by tomorrow morning. And in that realization, we can give ourselves permission to let them go tonight, to allow them to drift away into the vast, quiet darkness, like lonely embers fading in an infinite sky. The second lesson is the grace of impermanence. The universe teaches us that nothing, not even the most powerful star or the most massive black hole, is forever. Everything is in a state of slow, graceful transformation. Stars are born, they shine, and then they fade, leaving behind the very elements that create new worlds and new life. Galaxies collide and merge, not in a violent crash, but in a slow dance that creates something new and beautiful. Even the laws of physics in some theories might one day change. This is not a story of loss, but a story of flow. It is a reminder that life is a river, not a fortress. We often try to hold on so tightly to moments, to people, to the way things are, fearing change as a form of ending. But the universe shows us that endings are not failures. They are part of the cycle. They are the necessary and peaceful transitions that allow for renewal. To accept this is to find a deep and abiding peace in our own lives. It is to learn to appreciate the beauty of a moment without needing to cling to it, to love deeply without the fear of letting go, and to see change not as a threat, but as the natural and gentle rhythm of existence itself. It is the wisdom of the leaf that knows its purpose is to grow, to shine, and then to fall, returning its substance to the forest floor to nourish the next spring. And perhaps the most important lesson of all is the preciousness of now. all of these cosmic endings are so incredibly far away that they are for us abstractions. They are not our reality. Our reality is this one brief shining moment of consciousness in a universe that will one day be cold, dark, and silent. We are living in its brilliant golden springtime. The sky above us is filled with light. The world around us is teeming with life. And in our own minds, we have the astonishing capacity for thought, for feeling, for love, for wonder. We are, as we have said, the universe's way of knowing itself. And that knowing is happening right now, in this very moment, as you lie here breathing. The vast, quiet cosmos has given rise to a flicker of awareness that can contemplate the cosmos itself. That is the miracle. The story is not in the distant end. It is in the here and now. It is in the feeling of the blankets against your skin, the gentle sound of the air moving in and out of your lungs, the quiet presence of your own thoughts as they begin to soften and drift. So let the contemplation of the end of everything guide you back to the beauty of this one simple beginning, the beginning of a night of rest. Let the vastness of space remind you of the vastness of your own inner peace. Let the silence of the far future bring a deep and profound silence to your own mind. There are no answers you need to find. There are no problems you need to solve. There is only this moment of quiet, this gentle descent into the soft darkness of sleep. The universe will continue its long and patient journey. Its story is written in starlight and gravity, and it will unfold in its own time. Your story for tonight is one of rest, of letting go, of allowing the gentle cosmic lullaby to carry you into a place where time dissolves and all that is left is a deep and profound peace. Rest now. You are home. Good night.